For the last few years, I've been involved in part of sort of the emerging area of computational social science, which is basically the digital revolution for the social sciences, with psychology, sociology, medicine, everything that used to be person to person. How can we use technology to increase it? And basically, we have the potential to increase the understanding of individuals, groups, and whole societies in ways that we could have never done before, and in a breadth that we couldn't have before, and a scale of whole countries at the same time if we want to. And as an emerging field, we need new tools and new methodologies. And basically, we need to turn the whole area of big data and mobile sensing into something that is not just done by the artisans, the black magic that gives you a result afterwards, but to a field that you can teach in school, and later to something that everybody can do, just like the web. And this is something that I've been caring a lot about and how to do that. So I'll tell you a little bit about some methodology and some of the tools that me and my collaborators have been working on. And we'll start with the methodology. And in general, sort of the big inspiration here is from the medical realm, where MRI is one of our best tools right now to diagnose a living person, inside the chamber, and understand what's going on with them. And then there is functional MRI, where cognitive scientists are actually using interventions while a person is in the MRI, and they can actually look at before and after the intervention and actually learn how the brain works. What if we could do the same thing for a whole society, for a whole community? What if we could take that community, put them in that chamber, and actually look at how they interact with each other, how friendships are formed, how groups are formed, and how things evolve over time? But instead of a chamber and bring them to the lab, what if we could do it while they live their regular lives back home? And then not just look at them, but also do interventions that change their behavior, and we can observe our intervention while we can measure them while we do the interventions. So this is the big inspiration for the approach of the sort of the social MRI, which is combining a huge amount of data collection as people live their lives, together with targeted interventions that are focused on the community. And one way to do it is basically build a huge dome around a city. The Simpsons have done it, so it's definitely doable. The alternative approach is to use the supercomputer in our pocket that has all these sensors and can sometimes make phone calls. And basically, there are dozens of signals that are going through our phones at every given moment. Some of them are from the actual sensors, but some of them are signals from apps and what the user is doing that you could use to understand them better. And you can also reappropriate different signals and sensors that weren't meant for one thing into another. For example, we've been using Bluetooth to understand when two people are near each other, even though that was never what the developers of the standard meant. So we're actually using Bluetooth to indicate face-to-face interactions between people and understand that they're spending time together. And then in aggregate, with a lot of these phones, you actually have hundreds and thousands of signals coming together, flowing together in sort of this virtual imaging chamber. And if you have other types of data, you can also add financial statements, bioinformation, surveys. And this is why we're calling it a living lab, because there's some sort of agreement within the participants and us. It's not just that we're going and hacking their phones and devices. I've done a lot of this work and developed a lot of this work at the Media Lab, where I did my PhD with the Human Dynamics group, led by Sandy Pentland. And basically, after we had the general methodology, now we need the community to put under the dome. And so basically, we did a living laboratory with a residential community, which we named the Friends and Family Living Lab. And these were all grad student families. And it's important because it's different than a lot of communities where these type of sociological studies have been done before, because it's usually been with undergrads or coworkers. And this is whole families and who live their lives, and at least one partner is not in school, and half of them have children. So it's very interesting, much more realistic scenario to look at. And that community also had very vibrant community life. They had coffee hours and barbecues every few weeks and holidays. So they had a lot of interaction and interaction spots. And also they had diverse sub-communities. There were people from the same country of origin. There were people of the same religion, the same department. And we could know all that, so we can actually use this as we design the study and to help understand better. So basically, the study lasted for about 15 months, starting in 2010. And basically, in the beginning, we did sort of a pilot. We wanted to see that we can get what we really thought we could get, and that we wouldn't kill the user's batteries. As we developed the software, and we did kill the user's batteries many times. And slowly, basically, we were able to push updates until everything stabilized. And then we were able to ramp up in total we had 150 participants. Some of them graduated in the middle. And then we did different interventions after we learned the community, and we designed interventions based on the specific participants. And because it was an academic study, then it was supervised by the ethics committee of MIT, the Institutional Review Board. And of course, everything was voluntary with informed consent. They could delete their data anytime if they wanted to, but nobody actually did because they felt comfortable with what we were doing and wanted to contribute. There's also the usual boundary between researchers and the world where you never disclose the subjects and identity or any sort of information. And this is this first boundary between the investigators and the outside world. But we also, because of the sensitivity of this data, we actually added another boundary between ourselves and the participants, where no human-readable data or numbers were actually saved and stored. We basically took all the data and did a hash and an encoding, a one-way encoding, where we could still, if you call the same phone number 3 times, it'll always be encoded in the same way, but we don't actually know what the number is. In addition to that, my data was there all the time together, so I want to make sure that I felt comfortable with anything that is done with this data. So throughout the experiment, my data is inside the database as well. So in the end, after we finished, at the end of the study, we ended up with 1 million hours of human data, of behavior data. We have 53 years of accelerometer and movement, millions of scans and data points, together with a Facebook app that we had, together with receipts that people gave us and credit card statements, so we can look at how decisions are made, how you're influenced in your shopping from your neighbors, or if you come, you have a child and your shopping behavior changes. Are you influenced by your next door neighbor, or are you influenced by somebody who speaks the same language as you? So we wanted to look at sort of that, and that's kind of why we collected the financial information. And we ended up with what's probably one of the richest data sets of one single community over this period of time. And in addition to the data, because we talk to them, we know a lot more. So we know, we have all the demographics information. We know the age and religion and groups and affiliation of every participant. We know that 2 people are not just linked. We know this one is a spouse, and this one is a neighbor and a colleague, and this one is a yoga partner. And then we can start grouping them and understanding that this person is part of a religious group A and lives on a certain floor. And we can use this as we build our models and as we see how decisions and how behavior changes across this group. Another very interesting thing is that you can span many networks between the same people. These are just a few of the networks, but basically through the Bluetooth that I mentioned, we actually could span the face-to-face networks of interactions between the people of the community. We also had a Facebook plugin that collected their interactions in the same way. We have a phone call log, and also every 2 months we actually asked them to grade every other person in the study in questions like how close do you feel to them? Would you feel comfortable asking them for a $10 loan, for a $100 loan? Would you let them take care of your kids? So we have the self-perception of their social network and their mind. And the very clear thing here is that they're very different. And people who are central in one are not in another. And you could also see how the face-to-face network is the richest of all, because you spend so much time with these people. And so we're able to look and see what network correlates with what behavior and what types of information go on which type of network, which is has turned out to be very useful. And we didn't have just a snapshot of it. We actually have it over time, so we can look at these networks evolve. We can look how new students who integrate into the community over the year and how their network position changes. We had to develop some of our own tools to look at networks over time and interactions and at the same time. And then we did different interventions analysis on the database. And as far as what interested me, and I did have to graduate to, was that to sort of sample different things that you could do with this type of data as examples. And one of my favorites was a fitness intervention that we did, where basically we told them there's a fitness game and different people got different rules, and they could get a few dollars every few days throughout several months. And in reality, what we wanted to do is see if we can design and measure social mechanisms. And those were the rules of the game. So basically, we had a control group that basically saw their own data and got rewarded for it. We had another group that could actually see 2 other people, and 2 different people saw them. So basically, you knew that you're being watched by 2 people, and you could see other people and how they perform. And then we had a third group where you actually got rewarded for your peers' behavior, sort of a pay it forward. So your behavior rewards 2 people, and you get rewarded from other people in the network. And we wanted to see how this would affect. And this was in Boston in the winter, in fall to the winter. So when we started in October and we ended this in December, you would expect people to do much less activity, and not. If we had done this in the summer, or in the spring, then yeah, as the snow melts, of course, people move more and the weather. So we wanted to go against the trend. And basically, we saw that very clearly that the social groups had a much better performance. And within the social groups, we saw that the ones that had this social incentive had a much stronger impact. And people actually added 84 minutes of just movement a week, whether it's more up the stairs or more inside of elevator and things like this. An interesting thing, because we were doing this inside this big imaging chamber, we knew the relationships before we started. So we actually randomized the allocation of these groups. So we could actually see how the effect of when you're paired with people you know or with strangers. So we could see, for example, an interesting result was that when you're paired with either two strangers or two people that you know well, you had much better results than if you were paired with a stranger and somebody you knew together. So that was a very interesting dynamic that came out. We also had a bunch of other interventions. For example, we wanted to look at the link between sleep, mood, and how you socialize. Because these are things the socializing part is something we can measure easily with our technology. So we basically had a few people actually sleep for a few weeks with ZEOs, with sleep measurement devices, together with surveys and whatever we could collect from the phone. And we wanted to see if you could estimate when they had a bad night's sleep just from the phone data. And we had pretty good results in that. And then we looked at the different interactions. So we saw, for example, that your mood is mostly affected by your sleep hours and your spouse's mood, which is kind of natural. But it's just interesting to see that we can actually sense just healthy, we can do sensing in mass of a healthy population before they have to go in and get special measurement devices. We also did some personality trait testing because we did personality traits surveys with the participants. We also were able to correlate and infer some personality traits based on the people you are. And people, you know that your friends define you, and we could actually show that. And how your social interactions go, we can actually detect introversion and extroversion and things like this. We had some other interesting, again, offshoots into different directions. One was looking at the network effect and how things spread in the network. So one of the interesting things was that we could actually predict what apps people would install on their phones based on who they spent time with face-to-face. But we couldn't predict it if we just looked at the network of who they said are their friends. So basically, the people that we spend time with, even if we don't think are our friends, influence us a lot in the decisions that we make. And just looking at app installs was just a sample into seeing how this is done, how these decisions are made. We also saw a correlation between socialization to financial status. We could actually separate, look at how people behave and look at and estimate some financial differences between them, which was pretty interesting and a little scary. We also, one of the interesting directions that I'm really interested in is sort of learning about learning. Sort of when you want to do these data collection initiatives and campaigns, how long is enough? If you want to understand relationships in a group, how long is a week enough of sensing? Do you need a month of sensing, 3 months of sensing? So we looked at how our information was aggregated and sort of trying to develop techniques so that you can sense in the shortest time and with the least amount of battery. So maybe, something that's heavy battery, like GPS, is correlated with the signal that is collected just from what apps you're running, or if your phone is plugged in or not. We could use that cheap signal to infer about the expensive signal. And again, this is in our way to get this into the world and get people to use it in the world. And now we get to sort of the tools part, because we did the study, and during the middle of the study, Android was just beginning at the time, but more and more universities and colleagues and organizations were trying to do similar things, use phones as sensors. And we've already built a lot. So we decided, instead of everybody building their own silo, we decided to open source all of our work. And we're calling it Funf. The open source project is called Funf, and with the hint for the friends and family study where it started from. And it has the word fun in it, so it can't be bad for you. And also, you can make a cool robot with the letters, like Voltron. But what you can actually do with it, and the goal is, we want to lower the barrier of entry to the whole area of mobile sensing and big data and data collection. Because a lot of time, what's missing is the data that you want to use. And when I did machine learning projects in school, there were just existing data sets that you had to pick, from Enron, email databases, or things that were already public. But with this kind of technology, I could just, if I wanted to do a detector of running versus walking, I'll just run this on my phone, walk and run a few times, and I have data from my school project. And so we wanted to give developers and researchers and end users, including journalists, of course, inside that, the tools to tap into this world. So we have multiple offerings in this, from this project. One is called Funf Journal, which is basically a user app where you can download it from the Play Store, and it actually lists all the signals we can collect. And I think now we have around 40, maybe a little more than 40 signals that you can collect. And then you can set off how often they will come, and you can set the collection. If you set the collection incorrectly, you'll kill your battery very fast, but this is for you to play with, in a sense. And then, basically, everything is encrypted with a password you set, and you press a button, and it zips it and emails it to wherever you want. And so it's good for small studies. And then we also set up an option to set it up with a server. Here's a code, run this Python code on a server, and put this IP address on your phone, and it just uploads just like it did in our experiment. Then we realized that a lot of people don't know how to deal with servers and IP addresses, like people that we worked with, psychologists and doctors and sociologists. And so we hacked together something called Funf in a box, where we basically use Dropbox as your server. So basically, you could build a whole experiment in 5 minutes without any coding. You go to a website, in funf.org in a box. You approve it as a Dropbox app. Then you have the list of all the signals. You say what you want to collect and not. And then we basically build an Android app for you in the background, which bakes in the credentials. And suddenly, you get a new directory in your Dropbox account with the app. And then you install it on any phone you want, and the data will just flow into that account like a server. And then this enables you to do a really quick, behavioral study, really quick data collection with user studies and things like this. And finally, the hardcore option, which is the SDK, where it's a library. If you're a developer, you can now very easily integrate tapping into all these sensors and make smarter apps or make data collection. And you can build new sensors very easily in this framework. And you can use all these functionality that everybody has to do. How do you back it up? How do you deal when the user doesn't have internet connection? How do you deal with encryption? Stripping the human readable stuff. So it's all baked in as functions that developers can use. So this was a really nice experience from our perspective. We started getting emails from people, doing their PhDs with this, starting to see job postings for Funf developers, which was nice. We ended up winning the accelerator competition in South by Southwest, where we basically went to just pitch the open source part. And at Google I/O, we were invited to present as a developer platform, again, to get more reach, because it's basically just the three of us, basically me and two partners from MIT, Alan and Cody. And then we won the Knight Foundation News Challenge, which basically meant we could just drop everything we're doing and go to this full speed. And we created Behavio, which was our company, to both continue with the open source work, but also start building the technology and the stack for helping our devices understand behavior and context. And we were working on technology to allow both developers to make smarter apps and also some end-user apps, which we thought would give us a lot more impact. And then we had an opportunity to have even more impact with the Google acquisition. And so basically, we're continuing a lot of this work, but unfortunately, I can't talk too much about it yet because it hasn't launched yet. But what I can talk about is a little bit of my favorite projects and some of the things that you could do with this with this framework. So the One Laptop Per Child project has been using Funf in an experiment that they've been doing in Africa, where they were deploying tablets with educational software for children to learn on their own in areas where there are no teachers. And they basically were using the system to understand how children are learning and how they're helping each other and teach each other to learn. Somebody else is working on an App Inventor plugin for Funf so that you can actually build these data collection sensing apps graphically, like Lego bricks. A bunch of people are working on integrating sensors with it. So basically, if you have any sort of sensor that you want to collect, it's very easy to connect it to Bluetooth to the phone. And once you get it to the phone, Funf can take care of the rest. We can, it'll make sure it gets to the server, it'll make sure the data is cleaned, and it can actually make apps that use the data immediately. And if you look forward of the potential and the things you can do, and for journalism or for just regular, media enrichment. Today, when you take a picture, you have the GPS tag and maybe the time the picture was taken. But think about if you add all this extra metadata. When you take a picture, you can, if you don't just know where the photographer was, you know where they were going, how fast they were moving, what ambient noise was there, who they were with, and other things, which you can use to really enrich media. And you could also take it into other directions. An activist group is actually using some of this to help document when a photo is taken, actually recording the environment, so you can corroborate that the picture was actually taken where it was. And actually other people in the demonstration can actually verify that the other person was there because they have a similar environmental fingerprint that the phones have sensed. You can take it to sort of imagine, data donations by people. In Funf, you can actually have multiple types of data where you can say, I want to collect for myself everything about my life, but I want to donate anonymous data of certain types to another destination. You can actually set up technically, but we don't have the destination yet. But the idea is that imagine data donations of people that could help public safety, journalism. You can actually understand where things are going good or going really bad. When SARS started in Hong Kong, I think it was, 200 people from the same apartment building didn't show up for work. That was the ground zero. Imagine if you had some sort of public dashboard or journalism dashboard to understand this much faster than after the fact. Another example is, in disaster. Again, it's technology. It's the same software, the same things that you can do for yourself for your homework. Just walk around in a disaster area. You can map where the roads are working and when they're not. You can actually record where there's network connectivity and when there isn't. And you might even be able to detect people trapped because of the person-to-person detection. Again, if people had this. So there's the potential. Another thing I'll mention, and you mentioned the Cicada project earlier. So that same group is actually working with Funf together with air quality measurements. And what they want to do is look at bikers in New York and not just look at the air quality, but also correlate that and collect the data together with how fast they're moving and how fast they're breathing. Because you might be moving in an area that's not really polluted, but because you're breathing really hard, you're actually taking in much more pollution than if you were just walking in that area. So that's another project that's been used. And sort of to get things together, I don't know if you've read the news in the last few weeks about Popcorn Time. So Popcorn Time is an illegal pirate movie project, and which was taken down since. But basically what they did is the developers took a lot of existing technologies, torrents and subtitle sites and pictures of the movies, and basically created a Netflix experience for pirates, which is so simple that anybody could just install. And this was growing so fast and was threatening so bad that the movie industry had to shut this down within 24 hours. There are, of course, forks of this because it's open source, but I'm not advocating for it. But what is the version that we can do for our type of work? We have already all these open source technologies to collect data. We have free storage across many companies. We have data analysis tools, data visualization tools. What will be the Netflix version of this that you can get it to anybody to analyze? And this is sort of where I hope the direction of the community will go. And to sum up, so basically I've mentioned the social MRI approach as sort of the methodology. And then on top of that, one implementation of it was the Funf system that we deployed in the experiment. And on top of that, we did one study, which is the Friends and Family data set. And there are actually other groups doing similar studies in Europe and other places in the world, so we can compare across them. And then there's the specific analysis we already did on this data set. But what matters is not really the work that we've already done. What matters is the platform side. What can others find in this data set? What can others do with this software, and what can others do with this general approach? And I think this is what really matters at the end of the day. What others can do with the platforms and work that we provide. And sort of this is how I would end. And thank you for listening.